Trinomials, or expressions with three terms, can be factored by the following method. So what you're looking for is you're looking for a pair of integers that will multiply to the last number here, but add up to this number right here. So in this case, we're looking for two numbers that will multiply together to be 6, and those same two numbers need to add up together to be 5. So, if we take all the factors of 6, 1 and 6, negative 1 and 6, 2 and 3, negative 2 and 3, all of these pairs will multiply together to be 6. We're looking for the pair that will also add up to the number 5. And in this case, 2 times 3 equals 6. 2 plus 3 equals 5. So those two numbers multiply together to be 6 and add up together to be 5. So these are the pair of numbers that we're interested in. Now, when we get these two numbers, we can simply present them in the following format. We put our x at the beginning of the brackets and our 2 and 3 at the end of the brackets. So in this case, x plus 2 and x plus 3 is the expression x squared plus 5x plus 6 factored. And we can prove that by simply expanding it again using a FOIL method. And when we do, what happens is we end up with the same expression or same trinomial that we started with. So factor x squared minus 9x plus 20. So we're looking for two numbers that add up together to make negative 9 and multiply together to make 20. So we'll start by listing all our factor pairs that will multiply together to make 20. And these are 1 and 20, negative 1 and 20, 2 and 10, negative 2, negative 10, 4 and 5, negative 4, and negative 5. All of these pairs will multiply together to make 20. Only one of these pairs will add together to make negative 9, and that's the last pair right here. So these are the numbers that we're interested in. So our result will be x minus 4, x minus 5. We can prove that we've got the correct factor by expanding them again. And if we do so and end up with the same expression that we started with, then we can be pretty confident that we've done our homework correctly. Okay, so we're adding to get the middle number, and we're multiplying to get the last number. So x squared minus 5x minus 6, we're looking for a pair of numbers that multiply together to give us negative 6 and add together to give us negative 5. And when we write out our pair of factors, we look at the one pair of values, 1 and negative 6, which satisfy the requirement that they add up to negative 5. So 1 times negative 6 equals negative 6. 1 plus negative 6 equals negative 5. In our next example, we've got m squared minus 8m plus 12. So we're looking for a pair of numbers that multiply together to be 12 and add up together to be negative 8. So we list all our factor pairs of 12 right here. This should be a 12. Apologize for the error. So 1 times 12 equals 12, negative 1 times negative 12 equal 12, and so on, but only one pair, negative 2 times negative 6, add up together to give negative 8. In our example, x squared minus x minus 12, we're looking for a pair of numbers that multiply together to be negative 12 and add up together to be negative 1. Listing all our factors, we find that there's only one pair that will actually add up to be negative 1. So 3 times negative 4 gives us negative 12. 3 plus negative 1 gives us negative 1. This negative x, we have an implied 1 right here, so we were looking for a negative 1. In this example, x squared plus 10x plus 16. We're looking for a pair of numbers that will multiply together to be 16 and add up together to be 10. So we list all our factor pairs for 16 and then see that only one of these pairs, 2 and 8, will actually add up to 10. So our answer here is x plus 2, x plus 8. Two x squared plus 2x minus 12. We're told we have to common factor first. We want to get the terms inside the brackets. We want them as simple as possible. Okay? 2x plus 2x minus 12 is not that easy to factor. But if we take the lowest common denominator in this expression, which happens to be 2, we can reduce what's inside the brackets to a simpler expression. So 2 bracket x squared plus x minus 6 is much simpler for us to factor. So when we've done that, we're looking for a number that multiplies together to be negative 6 and adds together to be 1. Okay. And it just so happens that negative 2 and 3 multiply together to be negative 6, but add together to be 1. So when it comes time to writing out our factor, we start with this 2. We start with this 2 here. We write it in brackets, and then we use our x minus 2, x plus 3, which we discovered down here to complete the factoring. In this expression, 3x squared plus 18x plus 27, all three of these terms can be simplified by dividing by 3. So 3 is our greatest common factor. We start by putting that 3 out there. 3x squared divided by 3 is x squared. 18x divided by 3 is 6x. 27 divided by 3 is 9. So now we're looking for a pair of numbers that will multiply together to be 9, but add together to be 6. We write out all our factors for 9, and we find that one pair, 3 and 3, satisfy both those conditions. The 3 times 3 equals 9, 3 plus 3 equals 6. Once again, we start by taking this our greatest common factor, we write it on the outside, and then we write our two terms, which were both 3 in this case, x plus 3, x plus 3. So this is the fully factored form of 3x squared plus 18x plus 27. So, we're given a little word problem here. A rectangle has an area represented by the trinomial x squared plus 4x minus 21. Now, we're being asked to express area. Area is length times width. So we need to rewrite this expression as something where we can say something times something. Okay? Length times width. In this form right here, we don't have two terms that we can multiply together. But by factoring them, we will come up with two terms which can be multiplied together, one representing the length, one representing the width. So let's start by factoring it. So we're looking for a pair of numbers that multiply together to be negative 21, but add up together to be 4. So we'll list all of our factored pairs to get to negative 21, 1 and negative 21, negative 1 and 21, 3 and negative 7, and negative 3 and 7. Negative 3 and 7 match the conditions. Negative 3 and 7 multiply together to be negative 21, add up together to be 4. So we can write our factored form as x minus 3, x plus 7. Now notice here, we have two terms which are being multiplied together. Trying to figure out which one is length and which one is width is pretty straightforward. Generally speaking, we think of the length as being longer than the width. So anything plus 7, x plus 7, is going to be longer than x minus 3. So we can assume that x minus 3 will be the width, and x plus 7 is the length. Now we're asked to calculate the actual dimensions if x equals 50. Well, if length is x plus 7, then the length will be 50 plus 7, or 57. And if the width is x minus 3, then the width will be 50 minus 3, giving us a width of 47 centimeters.